Hi everyone, this is Professor Fernandez, and this is Class Notes A in Lesson 3. So let's see what we're asked to do here. We're asked to classify the three second-order differential equations listed above the definition. So let's scroll up a little bit here, and these are the three ODEs here. So I'm just going to label them with A, B, and C, and then let's classify them. So to do so, we are going to review really quickly the definition of a second order linear ODE. And notice that it looks very much like what we had seen from the first lesson for first order linear ODEs. And I'm just going to scratch out the part that wasn't there for first order linear ODEs. That's what it used to look like. And we used to call this the AFT function. We used to call this the BFT function. So now for second order, we're basically renaming these two functions and we're adding a term in front of y prime that could depend on t, and then we're adding a second derivative. So that is the new change to the second order linear ODE definition from the first order one. And as was the case before, we call the differential equation homogeneous if the right-hand side is 0, and non-homogeneous if it's not. So let's use all of that and see if we can classify those three ODEs. So let's start up here with the first equation. So I'll scroll down just a little bit. Okay, so A. So let's compare this ODE to this form. And we notice that it's already in the standard form, meaning that all of the left-hand side looks like all of the left-hand side over here. So that's great. So we can identify very quickly if it's going to be a linear ODE or not based on that by looking at the comparison of the two. So we have, looks like P of t here is t squared. Looks like Q of t is y, so far so good. And it looks like G of t is t squared. So that makes a solid linear second order ODE, and it makes it non-homogeneous. Because again, the t squared is the g of t and it is not just the zero function. Okay, so that classifies the first one for us. So let's classify the second one following a very similar procedure. So for B, when we start to compare things here, we see that it's not quite in standard form. This sine t is not present here, so that's okay. We could divide by sine t on both, on the rest of the equation and put it into standard form. But looking at the second term, we see something that is going to make it difficult for this to fit our description of a linear ODE. So in the definition for a linear second order ODE, the y prime term appears as a linear factor. So that's part of the reason it's a linear ODE. There is no dy dt squared or cubed or any other nonlinear function of y prime. But that's exactly what's happening up here. So this particular part of the ODE makes it nonlinear. So this is not a solid. So we're going to write down here, not a solid. All right, and then we'll finish it up with C up here. This time the dy dt, the second derivative part is fine. This has a coefficient of 1. There is no y prime term here, so effectively P of t here equals 0. There is a term that involves y, but again, it has a non-linearity, right? It does not involve y to the first power as it is appearing in the definition. It involves a y cubed. So that makes this a non-linear ODE. So we're going to write not a solid once again. And that's it for this class notes.